Problem 14 was by far the most frequently missed problem on Online Exam 2, and so I wanted to create a quick video to talk through this problem. Now what I noticed is that I was giving a lot of 3 out of 6 points when I was clicking through your guys' problems, when I was reviewing your online exams. A lot of you guys had the first angle correct, so a lot of you guys like this, oops, I grabbed just a random sample, one person's version of this problem. This person has the first angle correct, and then the second angle seems to be in the wrong quadrant. Now I've seen this over and over, so I grabbed a copy of this problem so I could create a video. Okay, so the first thing you should do is apply inverse sine to both sides. That's how we kind of undo that sine function there and get theta by itself. And so what you should start with inputting into your calculator is inverse sine of 0.7260495. The number of decimal places that my math lab uses in these problems is a little bit maybe obnoxious. It's a bit much, but I know. Okay, so you input that, and then you get about you get this first angle, 46.556. I'm just gonna, I guess I'll keep all the decimal places. Okay, and like I said, a lot of you guys did that successfully. It was finding the second angle that was more of a problem. So if we go back and think about this, I'm going to scooch this up a little bit. And let me rewrite the equation that we're solving. So we're looking for when is sine of theta equal to 0.726, well, 0.495, okay. For angles between 0 and 360 degrees. So if you picture the unit circle, oops, I'm not drawing. Okay, and sine is given by the y-coordinate on the unit circle, so I need to think about when is the y-coordinate about 0.726, blah, blah, blah. So I'm just going to put 0.7, just because I don't want to squeeze in all the digits there. That's going to occur twice as we rotate from 0 to 360 degrees, as we rotate around this unit circle. You're going to get one solution in quadrant 1, and that's what we just found, this 46 point, well, I'm going to round it to 0.6 degrees right here. There's another solution in quadrant 2. So that's the first thing to note. We're looking for a solution now in quadrant 2. Now, that angle in quadrant 2 will have the same reference angle as our angle over here in quadrant 1. So if this is 46.556 degrees, then we can set that reference angle down over here in quadrant 2. And then we're looking for this angle here. This is our, I'll call it theta 2. This is our quadrant 2 solution. So to find that angle in black, it looks like we should take a straight angle, 180 degrees, and subtract our reference angle over here, the 46.556, all that. And that's where you should get that second solution. So theta 2 is equal to 180 degrees minus the angle we just found, 46.556. I'm just going to ... that. And so we get our quadrant 2 solution. When you do that subtraction, you get this 133.44378, this solution here that my math lab has listed as the correct second angle here. So lesson learned here, let me get my pointer. You use an inverse trig function to find the first solution, and then you think about, okay, which quadrant contains possibly a second solution. And so once you identify the quadrant, you lay the reference angle down in that quadrant so that it's not a set formula. You're not always adding 180 to the angle you found or subtracting the angle from 180. It depends which quadrant. The way that you should calculate it depends on the quadrant. So you really do need to draw yourself a picture for these problems and figure out, okay, how can I find this second solution by putting a reference angle in the correct quadrant.